session for the first day of the Saudi Student Conference in UK. This session is going to be about security and cloud computing. Please welcome with me the session chair, Dr. David Dye, here. And I'm the organizer, Latif Al-Karim. During this session, we have different topics of presentation. It's going to be about two presentations about cloud computing and large data and cloud computing, and the other two about the security aspects in different systems. We are missing so far one presenter, the fourth presenter. I don't know if he's going to come later, or we'll drop the session, drop the presentation, and have more time for questioning the speakers. As you know, we have 15 minutes in total for presentation, 10 minutes for the presenter, and 5 minutes for questioning. I will help you in managing your time by raising these two flags when there's 30 minutes left and 3 minutes left and 1 minute left. So try please to be committed to time. And yeah, I will introduce our first speaker now. Our first speaker is SULTAN ALSHAMRANI from University of Liverpool. SULTAN is going to talk about discovering malicious behavior symptoms in cloud systems. Okay, it's yours.
Yeah.
Bismillah. Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome to my talk. I'm going to talk today about my paper which submitted to this conference under the title as appeared here, Discovering Malicious Behavior Symptoms in Cloud System. And you could see from the picture, I'm doing security in cloud computing. As Latifa mentioned, I'm a PhD student at University of Liverpool, and my name is SULTAN ALSHAMRANI. Let's start. In the beginning, I'll introduce my talk, then give you some background work. The main part of the talk will be about my contribution, which contain two main aspects: reduce max algorithms and enhanced version of reduce max algorithms, and finally the conclusion. The first thing is, what is cloud computing? I'm sure if you Google cloud computing, you will find a number of definitions, but I'm taking the suitable one here. Our best definitions, which separate the definition to two parts. First one, the application and service we're using over the internet. The second one, the hardware and software providing these services in data centers. The goal of cloud system is to power future data centers, highlight their virtual services, and accessing these services from anywhere, at any time, using any devices. Of course, the issue, the important issue is the security, which is very important to both providers and user of clouds. For this reason, any malicious behavior should be stopped if possible. Malicious behavior could be from inside the network, like data loss, or from outside the network, external, like attacks. The research is about discovering malicious behavior symptoms rather than discovering malicious behavior themselves. How to do that? By using network patrolling algorithms. This is similar to human pathology. If you go to doctor, the first thing the doctor check is symptoms. If you have headache, temperature, or other things. What the benefits? The benefit is to detect malicious behavior early and to do healing process. And we use mobility algorithms for this reason. We're taking it from reference number 4. And to understand mobility algorithms, we have to define these two elements. First one, forensic virtual machine. Forensic virtual machines are inspector to inspect symptoms. Are many or small virtual machines that control other virtual machines in order to discover symptoms. What is symptoms? Symptoms is abstraction of some characteristic that can be related to malicious behaviors. Example of symptoms: any changing or modification in memory code, changing of attribute of file, like time or size, surface mix attribute or snaps of code. This focus in mobility algorithms because it's very important to find which virtual machine we should visit to discover symptoms. P here mean virtual machine, which one? K, number of configuration. We have a number of configuration for symptoms. Like each configuration has a number of symptoms to be discovered. The value mean how is the symptoms inside this configuration. Are they dangerous or less dangerous? Disk mean how many symptoms discovered at this machine last time inside the configuration. And the size of configuration is how many symptoms in the configuration. For example, if we discover last time 2 symptoms, out for disk will be 2 and size will be 4. And the lambda is very important factor, is the delay. And we work heavily in this factor, and the T is the time from last time, is the waiting time for virtual machine. What I did, I introduced a new algorithm. We call it reduce max algorithms. After we collecting the size or the weight of virtual machine, we play with the vector lambda. We set configuration for the vector lambda. We call it uniform, arithmetic, harmonic, exponential, and random number for the delay time. And we calculate the weight out of all things for appearance of symptoms from this vector and from last visit, the waiting time. And we, in the code, we try to find the maximum waiting time. And by then, if we visit this virtual machine and report if there is symptoms or not, then we reduce the weight to 0. This is the algorithm. Uniform mean all virtual machines are same. How we to distinguish virtual machine in response to the appearance of symptoms. And as you say, the lambda for every virtual machine equal 1. And of course, if there is no symptoms, the result will appear like this. The waiting time will be same. Arithmetic mean weight 1 for virtual machine 1 will be equal 1, weight 2 equal 2, weight 3 equal 3, until weight n will equal n, this for arithmetic number, and the result appear like this. For small number of virtual machine, if we have just small number, it's around 1.4. For bigger number, like if we have 600 virtual machine, it will be around 600, around 1.2, sorry. Harmonic, it's a harmonic number for random, for lambda, it's 1 for virtual machine 1 over 2 for virtual machine 2, 1 over 3 for virtual machine 3, until 1 over n for last one. And the result is appear like this. For exponential, it's 1 over 2 power I. For I is any number of forensic machines, virtual machines, sorry, until 1 over 2 power n for last virtual machine. And the result show no scalability with exponential number in the system, it's around 1. Random weights mean choosing the weights randomly and independently for virtual machine from 1 to 10, for example, and the result is similar to arithmetic 1. In the beginning it's around 1.5, then go smooth to be around 1.2. And we're testing if there is any configuration resulting in worse total marks. And for arithmetics with progress to not much difference, also for linearly growing sequence. And finally, there is some small difference here. For any number of virtual machine under 40, it's around 1.5. But for bigger number, it's like what we see early, 1.3. Enhanced Fairden, instead if we reduce the highest in this current round, we're looking if each highest reduce after number of rounds, like after 6 rounds, this highest should be reduced after 6 rounds, we reduce it now. And there is no difference for, of course, for uniform, because all virtual machines are same. But there is some improvement for small number of virtual machines for arithmetics, and also for harmonic there is improvements. No improvement for exponential, except in the early beginning. And finally, I'll talk with you about many forensic machines, how they work. The first forensic machine will pick the highest weighted recency virtual machine, and the second one will pick the second one and reduce them in the same time in the same round. And the result, of course, like this: the green one for 2 forensic machine, the red one for 1 forensic machine. And unfortunately, exponential, other problems here is no more benefits from adding more forensic machine with the previous issue, the scalability. And here we show clearly the exponential one is stuck in the same number for more forensic machines. Also the harmonic number at 1 point, like if we have more than 6 forensic machine, it will be the same weighted or max, the same max. And there is improvement for others like arithmetics, uniform, and random. The improvement goes slow with more forensic machine, but it's still going better. And here the ratio tells us that arithmetics, uniform, and random benefit. The black, blue, and green, and yellow is going to increasing number of forensic machines.